Hey everybody, this is Garrett with Earth and Time, and today I'm taking you to one of my favorite places in southern Utah, and that's what is known as Parowan Gap. And I'm going to take you for both a geologic tour through this gap, talk about why it's here, why it's special, as well as show you some very special historic sites that are here, and even some prehistoric sites that are along this canyon. So come join me today. Let's check out Parowan Gap, Utah together. I'm so excited about this one. Let's get to it. All right, so we started about a quarter mile that way, a little less, maybe a fifth of a mile that way, and now we've worked our way in a bit. And I wanted to stop here and talk a little bit about the geology and a bit about Parowan Gap, and actually about the hills Parowan Gap resides in. And they're actually known as the Red Hills, and they get that name from this unit that you can see in front of me, that you can see has some red on it. That's on one side of the road, that's the south side of the road. Here's the north side of the road. It has the same kind of red unit. And this is known as the Grand Castle Formation. And this is a rock unit made of conglomerates, basically a bunch of large cobbles and gravel that were being shed off of mountains as they were being built just west of us. Along with that, I want to point out a very interesting feature, one that's very important for us understanding the topography that we see. We have hills here, and then suddenly we have no hills as we get out into the basin until we get to another set of hills. Why do those exist that way? Well, here's a nice example of what that is. If I come back here and I look on the right hand side and I see this red material, the Grand Castle Formation, and now I'm going to look to my left. As I look to my left, I see there's more of a buff colored to, I don't know, yellowish brown colored rock unit. It's very layered, right? We can see those layers much like you layer a cake, right? This is known as the Upper Iron Springs Formation, and this was deposited during the time of the dinosaurs, somewhere between 75 and 85 million years ago. Contrast that with, if we look at the conglomerate on the right hand side, the Grand Castle Formation, this is a much younger formation. This may be 60 million years old, 50 million years old, and we have to ask ourselves, how did a much younger formation that really should be on top of this end up immediately adjacent to it? And so this is a nice stop if you want to see a normal fault zone, or a fault that makes up things like the Basin and Range. So this is the type of fault that's dropping down. So it's dropped this young stuff down relative to this old stuff, and it's probably has a series of these faults, and eventually you drop down until you have a basin and no more mountains out there, and it's all been eroded off in that dry lake bed. Now pay attention to the rocks here. They have this iron or rusted color. It's why they're called the Iron Springs Formation. They actually have a lot of iron that was in the water that went through them that gave them that color and a real rusty color. The other thing to notice is how they're layered, the stratigraphy in layers like this. And if you pay attention up on the wall, you'll actually see what look like little lenses of rock within the other layers. Those are actually channel deposits. That story is really related to what we see here in the Iron Springs Formation. This formation that was from the time of the dinosaurs, which our next stop, we're going to learn a little bit more about the time of the dinosaurs and see what kind of evidence they left behind. All right, we've moved down about a mile, and at this spot is one of my favorite places along Parowan Gap, and that is the dinosaur track site that's here in Parowan Gap. Now, this dinosaur track site resides within the Iron Springs Formation, that section that I told you was 75 to 85 million years old, and we'll go walk around and take a look at the evidence the dinosaurs left behind. And not only that, maybe we'll see some evidence about what kind of environment were these dinosaurs living in. So this is the next stop for us on this geologic and historic tour along Parowan Gap. From our last stop, this is a great spot to take a look at the stratigraphy again with the units in the right order. We have the Iron Springs Formation, this ancient time of the dinosaurs kind of fluvial system or river system that once ran through here. And then on top we can see the Grand Castle Formation, or this conglomerate, where we saw farther down the road the conglomerate up against the Iron Springs Formation. This area you can actually see them in correct stratigraphic stacking order. Before we start looking at the dinosaur tracks, what I want to do is give you an overview of the stratigraphy, or the rocks that are here, and a little bit about the history of those rocks, because they're going to become very important for us understanding the type of environment and maybe the types of dinosaurs tracks that we're going to see here. So what we're in is what is known as the Iron Springs Formation, and this is a formation deposited towards the end of the time of the dinosaurs, which is about 65 million years ago. These are slightly older. People believe these are about 85 to 75 million years ago, but towards the end of the time of the dinosaurs. And what we can see in the Iron Springs Formation is a series of layers, much like you would layer a cake. You can see layer after layer after layer. What's interesting about these layers is they're slightly different. So you have layers that are more recessive and gray. These are usually muddier layers, so they have more mud in them. And then you can see the more resistive units sticking out. These are sandier, or what we call sandstone. And the environment that these types of rocks and this kind of stacking pattern represent is one that's usually related to some kind of ancient river system or kind of floodplain type system. So this would have once been a very lush area with rivers and probably ponds and lots of vegetation, very different than what we see today in the desert. And because of that environment, this was a great place for dinosaurs to roam, to eat. And because they were stepping in things like mud, right, along these river banks and muddy deposits, that meant their footsteps, just like we step in mud today, are preserved. Especially what happens is they step in, they leave their track, and then sand or something comes in over them and preserves them, and they become fossils. And those are actually what we're going to see today, and those are known as casts. So we're actually not going to see the actual footprint, so that would be the mold or what they stepped in the mud, but we're going to see the part that's preserved in the sandstones. And we can see there's abundant sandstones. We're going to see a lot of different tracks today, I think. If you come to this spot, you'll see they have a bunch of information on the dinosaur tracks here, on preservation, here's a whole section on how they form. You can come here and it talks about what I just talked about a dinosaur stepping in mud. Sand comes in, some kind of flooding event, and preserves them through time. So at this stop, they have a series of markers to show you where to start looking for the dinosaur tracks. Now, along the way, we'll take a look at some of the boulders that have come down as well. One of the things we can do as a geoscientist is we can look at what debris has come down from on high to start giving us a hint about what we're going to see as we get up to the actual outcrops. And in this case, I can walk up to a boulder like this, quite a large boulder, and I can immediately see, I can touch it. It's really coarse. It's very sandy. It feels like sandpaper. It's a sandstone, right? And so this is some kind of pretty coarse sandstone that came down. And those kinds of environments are pretty typical of places, maybe in a stream type deposit or maybe along a shoreline. So as I would start walking through here, there have been really 3 types of dinosaur tracks discovered in this area. Now, I just read a paper yesterday. Some brilliant work was done by some students out of Southern Utah University, which is only about 30 minutes from here, a little bit less, maybe 20 minutes. And they came and they've identified about 5 different sets of types of dinosaur tracks. I know 3 of them in this area. I'll hopefully be able to show you 2 of them for sure. I'm hoping I can show you the 3rd one. So the 3 are really a hadrosaurian type track, which a hadrosaur is like a duck-billed dinosaur, and those were probably the most prevalent dinosaurs in this area. Iguanodons, people know them as, or something to that nature. The other one are ceratopsians, like Triceratops. There are some ceratopsian tracks where you can see what they call a manus and a pes, a front and back foot. And then you have theropods, or you're going to have meat-eating dinosaurs, carnivorous dinosaurs. All right, everybody, take a look at these tracks and the size of them. So what we're looking at are 2 hadrosaur tracks on top of each other. To give you an idea about scale, I'm going to go ahead and put my hand down here. So I have to really pull this back. So here's my hand, and here's really the heel of that foot. So, or here, better yet, let me put my foot next to that foot so you can get an idea just how big those tracks are. So there's a track 1 here, there's a toe, there's a toe, and there's a toe. So that's the bottom track, or the bottom track. And then on top of that, there's another track, and you can see a toe here and a toe here and another toe coming out here. And you'll see each of the toes are at least as big as my foot, and I'm a size 11, and they're probably even a little bit bigger. Pretty impressive size tracks. And so these would be some hadrosaur tracks. And if I pan up, you actually see the piece of another one. So here's a toe, here's a toe, and the other toe has been broken off here. So the dinosaur was walking this way. In this case, they're walking that way. Now, this is a block that fell down from the cliff up there, so I'm not exactly sure what direction they were truly walking. Now, one other thing to point out here is we look at this rock. This is known as the Iron Springs Formation, and you'll quickly see this really dark color. This is iron staining, so this is iron that was left behind by water that flowed through this sandstone deposit. Pretty interesting. So it gets the name Iron Springs Formation. And with that, you can actually have pieces of wood that have been replaced by iron as well. And we'll see a lot of wood material off and on in here. We'll also see a lot of other types of critters that were living in this type of environment. One thing I'll point out just up from those tracks is you can see the large boulders that have come down here. Now we have big boulders of the Grand Castle Formation, so we can kind of see what that looks like. And we have all kinds of different colored boulders from the Iron Springs Formation, and some contain some pretty unique structures like these rings here, and these are Lisangang bands, and these are a function again of the fact there's been a lot of iron that's gone through this sandstone, or a lot of iron-rich water that has gone through the sandstone. So this track is a bit hidden, and actually it looks like it fell down, but from this angle, there's actually a toe here, the right toe, there's the center toe, and we can't quite see the other toe because it's wedged down, but if I try to give you a better view, here's one toe, here's another toe coming out, and there's another toe on the other side on the bottom of this block. So this is a little bit of a hidden one. So if you come here and you see there's a little sign right here, I was first looking at this block, but then I realized it's really in this section back behind. And it's another hadrosaur track. So far we've seen 4 hadrosaur tracks. So as geologists and paleontologists, one of the things we want to do is look at the rocks around us and around where we see those track sites and try to get an understanding of what kind of environment these dinosaurs were in. Now this is pretty interesting. So this is kind of a finer grained sandstone with probably some muds in it. But what's most interesting is you can actually see the preservation of portions of some wood, and you can see a lot of it's weathered out, but this is basically a cast of where there was some petrified wood in here, and we can see that in several places. In fact, we can actually see some of the bark structure still in here. We can still see some of the wood here, and so we can start getting an idea there was some kind of significant type of tree that was pretty plentiful in this area. I've said it before and I'll say it again, being a geologist is like being a detective, and really we're earth detectives and earth scientists, and it's our job to try to unravel the story. So I see there's a bunch of dinosaur tracks. Now through some research I know those are most likely hadrosaur tracks based on the type of foot morphology that they leave when they left their tracks. And now I can start looking around, seeing I see a lot of wood material in here, and I start looking at the types of beds above me, and I can start going, okay, with that kind of wood material, with the types of layers I see here, I can look at similar layers being deposited today and get an idea, okay, I'm in some kind of nice stream system, maybe some kind of coastal plain type system. And I say that because during this time, the ocean for this part of the continent wasn't too far away to the east of me. So during this time of the dinosaurs, there was actually a part of the continent was split in two, into a western island of the US and really an eastern island of the US. And that shoreline wasn't too far away from where we're at today. So these were streams probably feeding down to that shoreline. Pretty cool. And I love looking at all the iron staining. Now, all this iron staining is much later, and it has to do with some volcanic intrusions in the area. But what it does is it creates these amazing designs and almost like natural artwork within the rocks. As geologists, sometimes we let the rocks come to us. In this case, this is a big chunk of the Grand Castle Formation that we looked at stop number 1. And you can see it up there, that red color, which is why they call this area the Red Hills, is made up of this type of material. Now, what I want you to notice is how large some of these boulders are and gravel. Look, it's bigger than my hand. It's bigger than a basketball, right? And then you have stuff that's much smaller. So this would be a poorly sorted conglomerate. So this is telling me there's a lot of water moving through here, but we're probably pretty close to the source of where all this was coming from. And now there was a major mountain building event that was taking place during the time of the dinosaurs, all the way going forward towards the end of the time of the dinosaurs and into the post the extinction of the dinosaurs, known as the severe orogeny, or the severe mountain building event. And these conglomerates are probably a result of the eastern movement of those mountains towards this direction, and you had all this material starting to shed off of them right into this area. So here's another hadrosaur track. Unfortunately, somebody chipped off the middle toe. So you can see the left toe, the right toe. This is known as a metatarsal, or the ankle, much like chickens have. They have metatarsals and birds have metatarsals. And this would have been a nice central toe of another hadrosaur track. Although you can see my hand, for scale, admittedly much smaller than what we saw before. Well, I got to show you a lot of hadrosaur tracks so far, but let me go see if I can find the ceratopsian track. So I saw this track many years ago, probably 20 years ago. So let me see if I can remember where I saw where the ceratopsians or triceratops tracks are. And what's interesting about them, as opposed to the hadrosaur tracks we saw, which were bipedal, right? They walked on two. Of course, triceratops walked on four legs, and because of that, you're going to notice something a little bit different about this trackway, these tracks, because it's not a trackway, it's just a front and back footstep. But let's go take a look and see if I can find those for you. Unfortunately, as we're walking over to those, I was not able to find the theropod tracks. I know there's some underneath some of the ledges up here, but I wasn't able to find those today. And unfortunately, it's starting to rain, and I heard some thunder, so I want to be careful getting too far up onto the hills. Well, gang, as I was trying to find the ceratopsian tracks, I guess I'll point this out. I just found a theropod track I've never seen before. So one long toe, another toe, and another toe off on the other side. And you can see how it's a long middle toe, and these are not quite as rounded as those other tracks we saw. So this is some kind of probably theropod or meat-eating dinosaur. And of course, here's my foot for scale, so it probably is a little bit larger. If we take a look at the middle toe here, a little larger than my foot. Pretty cool to find a brand new dinosaur track. Never seen that one before. I wonder if others have found this one. If not, I will have to let the museum know or contact a paleontologist in the area. Really cool. As I'm looking for the ceratopsian track, the other thing I'll point out to you are in some of the sandstone, you have these long features. These are actually burrows from worms or crawdads or crayfish from the time of the dinosaurs that were preserved. So these would have been little worm crayfish holes, and we can actually see them in a number of places. So it also gives you an idea when we see something like this of what kind of environment we're living in, so we can take a look at what kind of environment were these creatures living in today. Pretty cool. And I have indeed found the ceratopsian trackways. How about that, Dr. Hammond, my mascot? So Dr. Hammond is right between two of the tracks. I'm going to move him over just a little bit. Thank you for being scaled, Dr. Hammond. Here's the front foot of a triceratops, or excuse me, a ceratopsian, and here's the back foot. So you can actually see its toes are very different and wider than what we saw with the hadrosaurs or even that theropod. So there's its front foot. We call that a manus, and you'll see how it has a pretty distinct shape to it. And then we can see its back foot. And in fact, if we look at the foot morphology of a triceratops, we can see these actually match up really well. And so I'm so happy to be able to show you some ceratopsian tracks, because as far as I know, they're pretty rare in the rock record to see these. The back foot, and you can kind of see its toes. See some of its toes preserved there with that sand, and then you can see its front foot. Pretty cool. Now, I don't know where the rest of it is. I wish I could find it, and I wish we could see the whole story about what this Triceratops was doing, but I'm really, really excited to be able to share this sample with you. While I'm standing up on this amazing vantage point, I was glad I got to take you along with me to look at these dinosaur tracks. And we got to see all three. We saw hadrosaur tracks, the duck-billed dinosaurs. We saw a theropod track, and one like I've never seen before, which was really cool. And then we found those ceratopsian tracks. We've moved another mile down the road, so the dinosaur tracks were down that way. And now we can see where we have the Upper Iron Springs Formation on either side, but there's something funky starting to happen. So if you start looking over here, you see fairly horizontal Upper Iron Springs Formation. You see there's something happening in topography, and then look at what the Iron Springs Formation is doing over here. It's up on in and protruding up into the air. So it's no longer flat, it's all slanting down away from us. And we'll get another view of this, but I wanted to stop here so you can start looking at this transition where the Iron Springs Formation was like this on the other side, and now we can see they're dipping up. But what's even more interesting is not only are they dipping up, but they've actually been all the way overturned in what is known as a large thrust fault. And that thrust fault runs somewhere through here, would be that contact. Let's go ahead and move a little farther down and take another look at what some of these fins look like, or these big overturned sections. And now you can really see how the Iron Springs Formation is almost vertical here, and actually approaches vertical in some of these beds over in this section. So what do we know? Well, when geology is deposited, it's usually deposited flat, especially if it's some kind of gravity driven or water driven system. And so this tells me a major event had to take place to turn these things on in. And again, we know from the timing of this area, from doing a lot of mapping, that this is part of what's known as a severe orogeny. And it's a big thrust belt where parts of the continent actually overrode itself. So it's kind of like scrunching up a carpet against a door, and imagine those folds rolling one on top of another on top of another until you get kind of a thicker section. And that's exactly what was happening here. In fact, what's great is you can still see the horizontal layers of the Upper Iron Springs Formation, so younger, and here's the Lower Iron Springs Formation, older, being put on top of the younger and getting overturned. Pretty cool spot as far as geology goes. One last thing to point out from here, another basics of geology, is we can actually see the vertical nature of some of the beds coming under here from the Lower Iron Springs Formation. And on top, that's that Grand Castle Formation that we saw, that conglomerate. And notice how it's flat. This is called an angular unconformity. So what this tells me is that this was overturned, exposed, eroded, and then you had the Grand Castle deposited on top of it. So this starts giving me an idea about the timing of this feature as well. So this feature had to be in place between the time of deposition of course, the Lower Iron Springs Formation and the deposition of the Grand Castle, because it's lying right on top of it. And straight in front of me is the truly impressive actual Parowan Gap that was carved by a river that ran through this valley and through this section we've already been driving, probably pretty parallel to the road that we're on, or in a similar path. And actually, as these hills were being raised up during the Basin and Range faulting, the river slowly cut down. However, before I get there, I want to look back at where we started from on the other side. In fact, you can see the Grand Castle Formation nice and flat there. We can actually see where some of the upturned Lower Iron Springs Formations at due to the thrusting. And now we've come in to a whole different area here where you can see all this red and all this buff colored sections in here. So there's a combination, I believe, of what's known as the Carmel Formation in here. So this is a Jurassic section, so now we've gotten older still. And parts of up here, the Grand Castle Formation. Sitting behind me is our last stop today, and that is to take a look at the actual Parowan Gap proper, which is actually made up of the Navajo sandstone. Now, anybody who's been to Zion National Park or Snow Canyon State Park in the St. George area, both of which are about an hour from here, will not recognize this as the Navajo sandstone. Usually it's this big red and white sandstone with big cross-bedded striations through it, representing ancient sand dunes from basically an ancient Sahara desert that used to exist here in North America. This is a lot different. You can see it's buff and tan and beaten up, and we saw the Iron Springs Formation, and we know there was a lot of iron-rich water running through this area, and it's probably a similar story for this section. Plus, we're sitting between a number of fault zones. In fact, you can see a fault right behind me here. There's a fault that runs right through there on that side, and then of course as you get on the other side of the gap, you'll notice there's no mountains or hills that we can see. That's because there's a fault zone on the other side of this. So this is what's known as a horst block, or a block of rock that's left up high as two faults drop down on either side of it, which means this is a really beaten up and fractured piece of rock. Now, as this was coming up, interesting enough, they think a river flowed through here at one time. And you can see where we're at here, and this is a nice aerial photo. So I'm standing right here right now, and we can look up at the gap there, and I can come back down. And this whole block came up, and they actually have a beautiful diagram of this. So there's a fault on each side of this block, and as this was coming up, this river, so here's that block represented by this block. We call it a horst block, and we call the stuff drop down on either side a graben. We can see the hill here, a horst. And as I pan to the left, you'll see you get down into a valley, a graben. And as this horse continued to come up, there's probably an old lake here or river coming through here as well, and eventually worked its way out through and cutting across this block as it was slowly raised up. And they call that a wind gap. It's pretty cool, and it's a pretty unique geologic feature to see, and one that's so unique and special that the indigenous people here thought it was a sacred site and carved petroglyphs all over the hills here. And I'll see if we can take a look at some of those before it gets too dark. And just in case we can't see all of them, here are some pictures of those petroglyphs you'll see through here, and some of them appear to be a solar calendar like this one that seems to track the angle of the sun through time here in the gap. But you'll see there's so many petroglyphs, and they've been being carved here for a couple thousand years at least. I'm going to go ahead and walk down this path and see if we can see a couple of these petroglyphs. And I just want to show you what this wind gap, as they call it, looks like, where a now extinct river cut through this mountain, this horst, as it was beginning to raise due to the start of the Basin Range. So I can zoom in on these petroglyphs and you get a nice view, and here's one of the ones I think maybe a solar calendar coming up and through there, but you can see so many petroglyphs up here. And like I said, they believe they are from the Fremont people, and one of the hypotheses is that they're leaving messages for generations and individuals that came through here. They were telling stories, they were talking about safe places to go, they were tracking seasons potentially, and maybe they had something to do with agriculture as well. Here's some more petroglyphs they can see on both sides. So I like that they also show how these images were made. They were done for pecking, so striking, making holes. They were done by scratching and incising using a sharp pointed tool, or braiding, rubbing something back and forth. There's also things called pictographs, which are painted on. And I don't know if there's any pictographs here. And this always brings up a good question of when is graffiti not graffiti and is historic. So here is somebody's signature from 1882, somebody who came through here as a pioneer 160 years ago. Oh, and right on cue they had the same thing. When is a rock inscription a historic relic? When is a vandalism? Many of the petroglyphs here also represent animals, and that's what they believe is being captured here from trackways of birds. Or maybe those are dinosaur tracks. Maybe they saw the dinosaur tracks on the other side as well. But examples of birds and snakes. And I know there's pictures of rams in here somewhere. I'm not exactly sure where they're at right now. As I start walking out, you can see the amazing scenery here in southern Utah and the amazing sunsets. Wow. That's all I can say as I'm coming to the end of this tour of Parowan Gap with you. I can't ask for a better backdrop than that. All right, thank you all for joining me today to take a look at these stops through Parowan Gap, Utah. What an amazing place. So close to so many things, and I think it gets bypassed a lot, so I want to make sure I shared it with you. I hope you enjoyed learning the geology along the way. I hope you enjoyed seeing the dinosaur tracks. I thought it was really cool. We found a whole new track that I don't know if anybody knows about that one, so I'm going to follow up with some of my paleontologist friends about that as well. Really cool to see the petroglyphs, see the story there, and then look at this amazing geographic place from a historic perspective from the indigenous people in this area, as well as the fact of how it was made geologically. All I can say is wow, and especially with this backdrop behind me right now. So with that being said, if you enjoyed this video, please like it. If you haven't already, please subscribe to my channel. Keep up on all my adventures. I'm always looking for new ideas. Please let me know. I happen to be in southern Utah right now, but I like to travel when I can and try to do videos in other places. Or if there's other subjects that you're interested in as far as geology, paleontology, or history, please let me know. So with that being said, this is Garrett with Earth and Time. Thanks for joining me today, and take care. See you on the next adventure.